Ladies and gentlemen, we will start our first lecture in the first module, Introduction. The module will cover the following topics in 4 lectures. The quality issue. Roots of Lean and Six Sigma. Concept of Lean. Concept of Six Sigma. The 10 rules of Lean and Six Sigma. General model of process. Lean operations. Fundamentals of the statistics. Process statistical analysis. Calculate the outlier using standard normal probabilities tables. Calculate the outlier using Excel. Exercise on the statistical analysis. Six Sigma process. Six Sigma quality. Cost of quality. Six Sigma project infrastructure. Combining Lean to Six Sigma. The MAIC approach. The project-based learning method. The following documents are ready for download. The course material in PDF. Standard normal cumulative probability table in PDF. Template for outlier calculation in Excel. The 2 activities to be done after the module in PDF and Excel. Cost of quality template. 3 instructional videos for normal distribution, binomial and Poisson distribution, and process statistical analysis. What is quality? Is there any contradiction between quality and production? For years, we have been hearing about quality management systems. The most popular ones are Universal Quality Standard, ISO 9001, Six Sigma, CAF, Lean Management, or Total Quality Management. Applying the quality guidelines increases the efficiency of companies' operation and ensures higher production rate. Further, meeting the requirements of the standard is regarded as a major benefit for the company. Producing the correct production without defective parts or outlier is meaning higher efficiency and better production rate. Meanwhile, quality is not testing the end product or work only in the end of process. Quality is the culture of continuous improvement. Quality is ongoing process starting with the design of the product and work within all the manufacturing process of the product. It is including all the manufacturing environment, even the financial and human resource departments. The root of both Lean and Six Sigma reach back to the time when the greatest pressure for quality and speed were on manufacturing. Lean rose as a method for optimizing automotive manufacturing. The history of lean manufacturing truly begins with Ford and his groundbreaking automobile manufacturing company in the early 20th century. Six Sigma evolved as a quality initiative to eliminate defects by reducing variation in processes in the semiconductor industry. Originator of Six Sigma. The answer to the question why Six Sigma was simple: survival. Motorola was being consistently beaten in the marketplace by foreign firms that were able to produce higher quality products at a lower cost. When a Japanese firm took over a Motorola factory that manufactured quasar television sets in the United States in the 1970s, the factory was soon producing TV sets with 1/20 the number of defects they had produced under Motorola management. They did this using the same workforce, technology, and designs, making it clear that the problem was Motorola's management. Eventually, even Motorola's own executives had to admit, our quality stinks. What is Six Sigma? We can say it emphasizes the need to recognize opportunities and eliminate defects as defined by customers. It recognizes that variation hinders our ability to reliably deliver high-quality services. It requires data-driven decisions, and incorporates a comprehensive set of quality tools under a powerful framework for effective problem-solving. As we can see, it requires a lot of efforts, but when implemented correctly, promises an improved operating profit. What is Lean? It focuses on maximizing process speed and reduce waste. It provides tools for analyzing process flow and delay times at each activity in a process. It centers on the separation of value-added from non-value-added work, with tools to eliminate the root causes of non-valued activities and their cost. The 10 Rules of Lean and Six Sigma. We begins with the 10 Rules of Six Sigma. 1. The customer will define the performance in your mill by defining the limits which determine the good and defective product. 2. You must understand the process. 3. The decisions should be taken based on data analysis and not spontaneous. 4. You must focus on the critical to quality. 5. Always use statistical models. 6. Pay very attention to variation. 7. Use standard methodologies. 8. Select project which has financial impacts. 9. Project governance structure. 10. Get support as possible from senior and high management. The 10 Rules of Lean. 1. Eliminate waste. 2. Minimize inventory. 3. Maximize flow rate. 4. Use pull production system starting from demand. 5. Try to meet customer demand. 6. Do it right from first time, do not wait to correct it. 7. Empower workers. 8. Design your process for fast changeover and lower setup time. 9. Partner with your suppliers. 10. Believe and work with culture of continuous improvement. Starting from statistical quality control, we have the business process re-engineering and total quality management. When combine both of them together, we create Six Sigma. And when starting from Ford production system, we have Toyota production system and philosophy of just-in-time. When combine both of them together, we create Lean. Integrating Lean to Six Sigma create the Lean Six Sigma system. This integration will be done through several tools and techniques. We will learn them during the course. The benefits of Lean Six Sigma for companies can be summarized in the following points. Data-driven decision-making that allows you to see how the numbers change to show improvement. Improved processes. Increased capacity throughout company. Increased revenues. Reduced costs due to fewer defects. Saved materials, time, and money. Continuous improvement throughout the company. When we come to the history of production and quality, early 19th century began the Industrial Revolution and factory system focusing on quantity, and the factories were working in isolated economics. After entering World War II, the United States enacted legislation to help gear the civilian economy to military production. During this period, quality became a critical component of the war effort and an important safety issue. Nowadays, the manufacturing mills are working in global economy with very high competition environment, so they have to focus on quality. What do you think will happen in future? What is quality from the product point of view? We can say it is the ability of a product or service to consistently meet design specifications. Consistently is the magic word in this definition, not only meet design specifications. However, we can say it is the ability of a product or service to consistently meet or exceed customer expectations. Quality is not best thing forever, but it is meeting customer specifications without outliers and consistent. For any process, there are different inputs like materials, energy, resources, and knowledge. Transforming process will be applied on these inputs in order to generate outputs like product, service, waste, and scrap. Our target in Lean Six Sigma is to reduce the waste and scrap, which generate due to the variation. The variation will come from other two inputs: the manipulated variables, which are adjustable, and controllable variables. the loads and noise variables, which are uncontrollable variables. Control the variation in the inputs, leads to reduce the output variation, which leads to less defective, and scrap. From now until the end of the lecture, we will make introduction about the lean operations. The lean goals are: eliminate disruptions, reduce setup and lead times, eliminate waste, reduce inventory, improved quality, increased productivity, increased equipment utilization, reduced scrap and rework, reduced space requirements. Now we want to know how production mill can achieve these goals. Why production lines? Why all this efforts to implement the lean system in the production lines? Simply because the production line is the most expensive place in terms of plant investment, production costs, and labor costs. There are famous 7 types of wastes in the lean philosophy, which should be reduced as possible. Transportation, moving people and parts. Inventory, parts waiting to be worked. Motion, unnecessary human movement. Waiting time, waiting for parts to arrive. Overproduction, too much parts produced. Overprocessing, process we have to do that doesn't add value to the product or service we are supposed to be producing. Defects, parts which are not right and need fixing. Example for lean at Hewlett-Packard. This example shows how much lean reduced waste at Hewlett-Packard. They can reduce the setup time by 20%, the scrap and the finished good inventory by 30%, the space by 40%, the lead time and raw material inventory by 50%. However, the big waste reduction was in the WIP, and it has been reduced by 82%. This slide shows the streamlines of production, with lean, and without lean. Please consider the material flow in the process as a stream of water. And, by removing any obstacles like inventory, defect, WIP, waiting time, from the flow of the material, will lead to smooth flow without waste. Now we will introduce the lean methods, and they are as the following. Use small lot sizes. Reduce setup time. Use manufacturing cells. Reduce defects by improved quality. Use little inventory storage. Level capacity using takt time calculation. Level production. Use pull systems. Apply preventive maintenance. Good housekeeping by using 5 S's. We will make a short introduction for every method in the next slides. However, detailed information will be introduced during the course. Reducing lot sizes leads to increase the number of lots. If we have a customer order for 10 pieces, and we will produce them with lot size of 10, this means that we have only 1 lot. However, if we divide the production into 2 lots, each will has 5 pieces lot size, and if we divide it to 5 lots, each lot size will be only 2 pieces. Smaller lot size will reduce the inventory, leads to less space and less rework. Smaller lot size will increase the production flexibility, and make it easier to balance the operations over all the process. All these improvements leads to lean approach. Here is description how small lot sizes with frequent orders can reduce average inventory. The red line represents large lot size with 200 pieces, which leads to average inventory of 100 pieces. While, if we reduce the lot size to 100, the average inventory will decrease to 50. According to the total inventory cost formula, the total inventory cost equal to the holding cost, which decreasing with smaller lot size. plus the setup cost, which increasing with smaller lot size. This increasing, due to increasing the number of setups. The total overall cost will increase with the decreasing of lot size. To solve this issue, the setup time for each lot must be reduced, in order to reduce the setup cost. Reducing the setup cost will lead to new optimal lower lot size point, with suitable total inventory cost. During the course, we will learn how to calculate the minimum safe lot size, and the optimum lot size taking into consideration all the process parameters. As we know from last slide, setup reduction is very important to reduce time waste and total cost, because smaller lots leads to frequent setups. So, setups should be quick and inexpensive. This leads to short setup, which requires holding less inventory. However, workers should be trained to their own setups. Example to reduce setup times is using of standard fixtures for many type of parts. What is single-minute exchange of dies, Smed? It is a system of dramatically reducing the time it takes to complete equipment setup or changeover. The objective of a Smed system is to convert as many internal setup steps, which are performed while the equipment is stopped, as possible to external, which are performed while the equipment is running, and to simplify and streamline the remaining steps. The name single-minute exchange of dies comes from the goal of reducing changeover times to the single digits, for example less than 10 minutes. We will cover this point in details with examples and exercises during our training course. Manufacturing cells. Lean objective from the idea of manufacturing cells is to reduce movement of people and material, because movement is one of the 7 wastes. Lean requires the following in the manufacturing cells. Use work cells for product families. Movable or changeable machines. Short distances. Improve employee communication. Little space for inventory. Delivery directly to work areas. Work cell guarantees less movement and smooth flow comparing with process layout. Why reducing defects is very important for lean? Because occurrence of quality defects during the process can disrupt the orderly flow of work. When defects occur, problem solving is very important to reduce defects, and you should focus on finding causes of problems. Also, you should try to adapt automatic detection of defects during production if possible. However, never-ending quest for quality improvement. What's better than fixing something when it's broken? Stopping it from breaking in the first place. This technique is called poka-yoke, and was born out of the Toyota production system. At its core, poka-yoke is extremely simple. Any addition to a process, which is included to change the behavior of the person operating the process, with the intention of reducing mistakes, can be referred to by the concept poka-yoke. We will discuss poka-yoke in details during the improve phase of Lean Six Sigma. Lean objective is to eliminate inventory by eliminating problems before they happen. The main Lean inventory goal is to have only the minimum inventory needed to keep system running. There are several techniques to reduce the inventory. Use a pull system. Develop just-in-time delivery systems with suppliers. Deliver directly to point of use, no storage. Use group technology. Inventory can be likened to an asset or evil. Lower inventory level is like a seawater level, which will uncover hidden problems or rocks. Example of rock problems are late deliveries, process downtime, bottlenecks, poor quality, waste. Lower inventory will uncover these problems and let us store them for better operation. But, please try to remove the rocks first, then, reduce the water level. Once large rocks, problems, are removed, water level, inventory, can be lowered. What is level capacity loading? It can be achieved by leveling daily mixed model schedule. This will lead to stable, smooth production, as the following example. If we have a workstation with capacity of 3,000 units per day, while we try to make 3,900 units on Monday, and 3,300 units on Tuesday, and 2,800 on Wednesday, this will lead to shortage of 800 on Monday, and shortages of 300 on Tuesday, and surplus of 200 on Wednesday. The total shortage will be 1,100, and the total surplus is 300 units. Leads to cumulative shortage of 900 units for the 3 days. If this amount is distributed over the 3 days, a 3,300 units, which is 10% above the capacity, would be a solution. Then we will try to produce 3,300 units on Monday, and Tuesday, and Wednesday. The cumulative shortage will be 0. Hijunka is a Japanese term to describe production leveling. The distinction between leveling demand and production leveling is important, because we cannot control demand. What we can control is the rate of workload, information, material, raw good, finished goods in fulfillment, or actual production enters the operation. One of the main lean operation techniques is to change over from push system to pull system. Push system is the system for moving work, where output is pushed to the next station, as it is completed. Pull system is the system for moving work, where a workstation pulls output from the preceding station, as needed. In pull system, workflow is dictated by next step demand. An example for the pull system is the Kanban system. The pull systems will cover in details during the improve phase of Lean Six Sigma. Preventive maintenance means to make the maintaining for the equipment while it is in good operating conditions. It means replacing the parts that have tendency to fail before they actually fail. Good housekeeping. Maintaining a workplace that is clean and free of unnecessary materials. This is the 5S techniques. The 5S will be covered in details in the improve phase. The following table shows a summary for the difference between the traditional and lean systems for inventory, lot size, setups, queues, quality, vendors, maintenance, lead times and workers. Thank you, and see you in the second lecture of Introduction.